Hello everyone, welcome to Legacy IAS. So we'll be continuing with our class 8 science NCERT. This is chapter 4, which is electricity, magnetic and heating effects of it. Now, fairly simple chapter. Okay, some concepts we have to see. That's it. Now, see, one thing, see, the core of this chapter is this. See, electricity and magnetism, these are interrelated concepts. Now, through changing of electric or electricity, we can create magnetic field, and by changing magnetic field, we can create electricity. Okay, we'll understand how it works, this, that, but in general, you can understand that these two are interconvertible in a way. Now, let's get started. So, what it says, let us investigate this, that. So, basically, what it is doing, for example, it placed two needles here. Correct. Now, two needles are placed and they are two nails are placed and they are connected to a battery. Can you see this diagram? Correct. Now, in the middle they have a compass. Now, if electric current when passes through a wire, if it generates any kind of magnetic field, then only this compass will move. Otherwise, it will remain as it is. Now, what we observe is this compass starts moving vigorously. This compass starts moving very vigorously. Why? Because so close to it is some magnetic field being produced. Correct? And from where you're getting this magnetic field? By the flow of current. We'll understand why it is getting generated and all that. This is just an observation. Then, so when the current stops, the magnetic field disappears and the compass needle returns to the original direction. Correct? That means it is not because of the wire, it is because of the current flowing through the wire. Correct? Now, the region around the magnet or a current carrying wire where its magnetic effect can be felt, such as by deflection of compass needle, is called magnetic field. So this is magnetic field where you can feel the changes. Now, next thing, when an electric current flows through a conductor like a wire, it produces magnetic field around it. Correct? This phenomena is known as magnetic effect of electric current. Magnetic effect of electric current. Now, by the way, in some earlier chapter that we had about magnetism in class 7, in that we had learned that magnets, when you were taking a spool of wire like this or a solenoid, and from that you were passing magnet like this, some electricity was being generated. So you have already seen the when electric current is generated by moving magnetic field. Now here you are seeing magnetic effect of electric current. Now, so this is about one scientist. This is Hans Christian Ørsted. Now also he had also worked on this to show the connection between electricity and magnetism. Then, now this has many practical applications. Magnetic effect of electric current. Correct. Now all this is fine. See, electric bells. Correct. Then motors, fan, loudspeaker. All of these are using this. Now one of the most key thing that you must know is electromagnet. What is electromagnets? Electromagnets is when electricity is being passed through something that starts behaving like a magnet only when electricity is being passed through it. That is why they are called electromagnets. Okay, now see this. So if you see it here, there is a wire and that is connected to a battery. Now, can you see that this nail has started attracting small pins? Why it is starting to attract small pins? Now these small pins may be made up of what? They may be made up of iron or some magnetic material. Correct. Now why it is getting stuck? That is a very clear example that because of this electricity, what is being generated? Magnetic effect is being generated. Understood? Then now a current carrying coil that behaves as a magnet is what called electromagnet, that we have already understood. Now, now see this. Now it talks about what a freely suspended magnet does. So you might have seen, we have seen this in earlier classes also, that if you leave a magnet like this, you just suspend a magnet like this. Now a freely suspended magnet rests in north-south direction always. Why north-south direction? Because our earth itself behaves like a giant magnet. Now, why does earth behave like a magnet? Because deep inside the earth, the movement of liquid iron in the core creates electric currents. Because movement of in that core, there is movement of liquid iron. Correct? So iron is moving like this. This creates electric current, which in turn will generate magnetic fields. Understood? Now, many migratory birds, this has been shown recently. Some kinds of birds that go from, let's say, Siberia and they come to India some during the winter season. Now, how are they able to navigate? There are so many changes in the weather patterns. There are so many new things that come up. Okay, some electrical wire, this, that. Now, how they are able to navigate and get directly at the same place? So, basically, if you know, there are many birds that come from Siberia to Cover Lake in Bihar. Now, how they are able to navigate? Because they use this Earth's magnetic field and they are affected by it. Based on that, they change their directions and they try to reach at the same place again and again. So, the Earth's magnetic field also acts as a shield, blocking harmful particles from space and helps protect life on Earth. Now, what is the example of this? During solar storm or any kind of charged particles, when they come towards earth, because of the magnetic poles of earth, if you know what, if you remember, when we were dealing with magnets, we had seen one photo in which most of the iron fillings iron fillings were stuck on the at the end points of the magnet, because that is where the magnetic field or magnetic effect is the strongest. Correct? Now, because they are stuck like this in on earth also, because of the earth's magnet, what will happen? They will go towards the poles, and that is why on the poles, what you see auroras. Correct? Northern lights, southern lights, what are those are auroras, because of earth's magnetic field interacting with charged particles coming from the space. Understood? Then we come to lifting electromagnets. Now, what are this? Lifting electromagnets are strong electromagnets that may be hung to the cranes. Now, what is this? So basically, now you might have seen this over a dump yard. They go by a crane and they have a metallic plate like thing here. Now, this is this is able to attract all different magnetic materials towards it. Now, why? Now, of course, you cannot keep a very large magnet and manage it all the time. That is not needed and that is not done. What is done? They create electromagnets. That is, when electricity is being passed through it, then it becomes a magnet. It attracts things. And when you switch off the electricity, it is just a simple metal plate doing nothing. So, this is called lifting electromagnets. Then, so widely used in factories, scrap yards to move, lift, and sort metal, heavy metal items efficiently. Then, next thing, we have learned that when electric current flows through a conductor like a wire, it produces magnetic field around it. This we have already seen. Correct? Now, in the higher grades, you will learn even more about this wonderful link between electricity and magnetism. Okay, then Let's see next. Now, you may have observed that nichrome wire feels warm when current is passed through it. Now, so we are trying to understand why things are heated when current is passed through it. Correct? Now, let's see this. So basically, if you take a wire, let's say made up of nichrome, now what happens? This actually has some resistance to the flow of current. Now, because of this resistance, what happens? It starts to generate or lose energy in the form of heat energy. Okay, so let's see this. So, you may have observed that nichrome wire feels warm when current is passed through it. Correct? You must have touched something, you must have felt warm. Then, this happens because when electric current flows through any conductor, it faces some opposition or resistance to its flow. Different conductors offer different level of resistance to the flow of current. Nichrome wire, for example, offers higher resistance compared to copper wire. This resistance causes some of the electrical energy to be converted into heat energy. There was also a PYQ in which they asked that why heat energy is generated. It is because of the collision of atoms and molecules inside it. So some amount of electrical energy is essentially lost to us. Correct? It is not getting to our system. Where it is getting lost? In the form of heat energy. Then when electric current passes through a conductor, it gets heated. This warming is known as heating effect of electric current. So you have understood magnetic effect. Now this is heating effect of electric current. Then now, so basically what this heat is dependent on, how much heat is generated, this depends upon the magnitude of electrical current. The heat is generated in a wire depends on the material, thickness, length of wire, and the duration for which the current flows. Okay, so these are the functions on which heat that is generated in a wire depends. I can write the formula, but not needed at this level. Okay, I square r, if you remember, some people would, into t and all that. Then now I understand why does the torch lamp becomes hot after a while. You understood? Same electrical current is flowing and it is being obstructed, some resistance is being provided, so some electrical energy is being converted into heat energy. Then see this, these are important use cases based on the same principle. Then but sometimes it can cause problems like energy loss in wires during transmission. Correct? A lot of heat, a lot of energy is lost in just transmission. Correct? Then sometimes it may lead to some kind of short circuit or something because of which the socket or the plastic melts around it. So all those are also possible. Then then of course it is very useful in industries also. For example, if I want to create a high temperature furnace to heat things, for all that same thing is used. Then 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 it talks about batteries, that there are some different kinds of portable sources of energy, in this case battery, and how do they work. So now they have explained how does a battery work. See, battery working is very simple. First, let's understand the very basic cell, which is the voltaic or galvanic cell. Now, what is this? It contains two metal rods, okay, now made up of different materials and a liquid called an electrolyte placed in a glass or plastic container. Correct? So, this is a container. In the middle, what you have electrolyte, and this is electrode 1, this is electrode 2. Correct? And current is flowing through it. Now a chemical reaction between the rods and the electrolyte produces electricity. Over time, the chemicals get used up and the cell stops working. It is then called dead and cannot supply any more electricity. So a very simple one they are talking about. So here what happens, I can tell you in a very general way. So let's say there are two electrodes. Now they are made in such a way that one of them wants to lose electron and one of them wants to gain electron, and it will continue till whatever extra electrons it wanted to lose it has lost, and whatever it wanted to gain it has gained, and then after that it stops working. Now because there is flow of electrons, that this electrode to this electrode has to take place, and the electrolyte is not a medium from which it can go. That is why you connect it through a wire, and in this wire you start seeing flow of electrons or flow of electricity. That's it. Now here if you place a bulb, the bulb will blow, correct? Here if you place any kind of, let's say, fan, the fan will start moving, same thing. Now, so why it is called voltaic and galvanic cell? Because of these two scientists which worked on this, Volta and Galvani. Then now it tries to do something similar to the LED bulbs, and here it has connected it to lemon. Okay, now if you see here a glowing LED. Now in LED, if you remember what matters in LED, here also you want flow of ions, correct? So it can provide it. Then in LED, if you remember what we had learned, that LED allows flow of current only in one direction, correct? That is why it said that you try from one side. If it does not work, you just reverse the LED and then it will start working. A glowing LED indicates that your cell is working. In this cell, the metal electrodes are the copper wires and the iron nails, correct? The electrolyte is the lemon juice, correct? What is lemon juice doing here? It is allowing the passage of electrolytes or passage of ions, correct? So that is the electrolyte, and you have iron nail and copper wire which helps in conduction of electricity. You may also use salt solution instead of lemon juice. In fact, like we did this using, in our school we did this using ash can also act as an electrolyte in the same way. You put two electrolytes and two electrodes and it will start showing some amount of current flow. Then it talks about some common pairs. For example, this, the most famous one, zinc and copper. So here zinc is usually the negative electrode and copper is usually the positive electrode. Negative is the one which wants to lose electron, correct? So it will have a lot of electrons around it. That is why negative. So zinc is negative, copper is positive. Now what will happen? Zinc is more reactive. It will try to give electrons away. Copper will try to take those electrons. What you see? You see flow of electrons. And that is why you get a cell or battery here. Then next is dry cells. Now dry cells are one of the most widely used electrical cells today. They are called dry because the electrolyte is not liquid but a thick moist paste. This is the battery that you have seen, correct? So instead of that liquid electrolyte, you are using some dry electrolyte like a paste, nothing much. So here if you see in the middle, this this in the middle, this is made up of carbon and with a metal tip, and what is this? This acts as a positive electrode. So this acts as a positive electrode and the covering around is of zinc. So this zinc acts as a negative electrode. In the middle you have something filled, which is the electro, correct? Now, so basically it consists of a zinc container which acts as negative terminal and a carbon rod at the center covered with metal cap that acts as positive terminal. The carbon rod is surrounded by a paste like electrolyte. Then now in this case, because the ends are very fixed, correct? Zinc is the negative one and the carbon one is the positive one. So zinc will want to lose electron, this will want to gain electron. So the flow is very fixed. And once the flow is done, once all the electrons, whatever movement had to be done, that is done, then the battery is useless. Correct. But there are also something that we know as rechargeable batteries. Now, what are these? Rechargeable batteries are those which can be recharged and used multiple times. Of course, this will save money, will reduce wastage, all that. Then, rechargeable batteries also do not last forever. After being charged and used many times, they slowly wear out. So here, what rechargeable batteries provide you? It provides you flow in two directions. So at one time it is providing energy. So let's say from here to here the flow is there. Now, if you connect it to some form of electricity or some other battery, whatever, then it forces ion in the opposite direction, and now it is charged. Okay. So this is how rechargeable batteries work. Then, for example, the most famous example is lithium ion. Lithium ion is the most common type of rechargeable battery that you have in your phone, laptop, everywhere. Just connect it and you will start getting more energy out of it. Correct? After it is charged, you can use it again. Then it talks about solid state batteries, correct, which can replace the liquid or paste like electrolytes with solid material. So first was liquid, then better than liquid was the paste, and now it talks about solid state batteries. Now these are also common right now. So solid state batteries, these are why? So because there is no leaching. Leaching means some part going here and there and mixing up, all that is not possible in solid state batteries. That's why they are much more safe, and that is the reason they are able to last longer as well. And then developing environmental friendly sources of electrical power is a very important need that we have as humans today. Okay, so this is it for chapter 4. Then let's get to chapter 5, which is exploring forces. Again, a very simple chapter. We just need to understand some different kinds of forces and we are done. Yeah. Now, what is a force? What is force? See, generally, a push or a pull applied on an object is called force in science. A push or a pull. Correct? Now, what can a force do to the objects on which it is applied? Now, this you already know, correct? If you are catching something or you are pulling a rubber band, all these are different kinds of forces, correct? Then, now what it can do, the force applied on an object may make an object move from rest, correct? May change the speed of object if it is moving, yes. Change the direction of motion of object, yes, correct. Then bring about a change in the shape of the object, yes. For example, I can take this piece of paper and I can move it like this. I can fold it like this. How I can fold it? By applying pressure, correct? So I'm changing shape of the object. All these you understand. Now, one more thing you need to understand is, I'm not, see, this is according to Newton's first law of motion, that a body in motion remains in motion, a body at rest remains at rest unless and until an external force is applied to it. Now, if you don't remember all this is fine. So for any of these changes to be caused, you need a force. A force is needed to move an object, to change the speed of an object, to change the direction, to change the shape of an object. Otherwise, objects remain as it is. Then are forces an interaction between two or more objects? Yes. Yes. Now they are giving the definition. Same. A force is a push or pull on an object resulting from the object's interaction with another object. Correct. Force is always defined for two or more objects. I am pulling you, you are getting pulled. Now, can I do it without anybody, anything? Can I pull something like this? No, it does not make any sense. So, force is usually involving two or more people. The SI unit of force is Newton. Okay, then now this is coming from Newton's third law of motion, if you want to know. So basically, it says that when you pushed the table with your hand, did you feel a force on your hand too? The moment you stop pushing, the force on your hand also disappears. Right? Like if I start pushing something, I feel a force here on my hand also. What is that force? That is the opposite force that is being applied by the table, for example, on my hand. Correct? So once you stop pushing, then you stop feeling the force also. So whenever two objects interact, each object experiences a force from the other. Understood? Then it comes to different kinds of forces. What are the different kinds of forces? There are contact forces. Correct? What are contact forces? Which can be direct or it can be indirect. Like direct can be using our hands, indirect can be using a stick or rope. Now, so basically, which act only if there is a physical contact between the objects. These are called contact forces. Correct? So what are contact forces? That can be applied only by a physical contact. Correct? If there is no physical contact, then you won't be feeling any kind of force. These are called contact forces. Example, very famous example of this is muscular force. Correct? Now muscular force is basically whatever, like I am pushing you, you are pushing me, all that. Also, so basically muscular force is resulting from the action of the muscles. So muscular force occurs when muscles contract and elongate while doing any activity. Contract and elongate. This is also used when I gulp something inside my body, like this. So what I am doing? So my muscles are first contracting and then elongating, contracting and elongating, eventually pushing the food inside me. This is also example of muscular force. Muscular force is an example of contact force. Then yes, this we had seen. Now we come to friction. Now we learned that a body in motion remains in motion. A body at rest remains at rest unless and until a force is applied to it. Now, if I push something, like I push this, now why does it stop? Why does it stop? It should not stop. So there must be some force acting. What is that force that is acting against it? It is the friction. Friction is a force that opposes relative motion or opposes motion. So it will act in opposite direction to the relative motion or motion, opposite to the motion. So if a body is moving like this, the friction will be in this opposite direction. Correct? Now, so this is friction. The force that comes into play when an object moves or tries to move over another surface is called force of friction. It always acts in the opposite direction in which the object is moving or trying to. Correct? This is a contact force since it arises due to two surfaces being in contact. Now, a friction actually comes from irregularities between two surfaces. Okay, now if there are more irregularities, then there is higher friction. If it is smoother, then the friction is less. That's why if you are driving on a very smooth road, even if you stop applying any acceleration, you just leave your hand, legs like this, the car will go for a very long time at the same speed or will stop after a very long distance. While if it is potholes, you will stop after a very small distance. Why? Because the surface is irregular. Then, then force of friction depends on the nature of the surface. Then now one thing you must remember that air, water, all these also apply friction. Correct? That is why if you have seen airplanes, if you might have seen fishes, they all have a streamlined design so that they can reduce the friction that is being applied on them and they can move forward very quickly through the liquid or through air. Correct? Then, then it talks about non-contact forces. What are non-contact forces? Where you don't have to be physically touching or indirectly touching, you need not be touching at all, then also it works. Example is magnetic force, correct? If you put two magnets, same poles, close to each other, not touching, they just repel. If you put unlike forces, they attract each other, so they move close without being in contact. So this is one example of non-contact force. Then there is something known as electrostatic force, very important. Now understand this. One example I will tell and it will be fine. So you might have seen this, that if you keep some few pieces of paper like this, now paper does not have any charge on it. Now if I take, let's say, I take a comb and I rub it on my head like this, and then I move it close to the paper gets attracted by the comb. Why does that happen? That happens because of electrostatic force, correct? Now let's understand what has happened here. So the paper pieces get pulled towards the plastic scale or straw and stick to it when it is brought close to the paper pieces. Why does this happen? When two objects of certain materials are rubbed together, electrical charges build up on their surfaces, correct? Then these charges are called static charges. Why they are being called static charges? Because in this case the charges are not moving. That is why they are called static charges. If the charges are moving, what is that? That is electricity. Movement of charges is electricity. So here you have static charges. Charges are not moving, but one of the body acquires static charge, and this is called a charged object. A charged object attracts another charged object which is of opposite nature, or an uncharged object. So in this case, because that comb got charged by rubbing this, so comb got charged with any kind of charge, positive or negative, does not matter. The paper was uncharged, so it will attract the paper, correct? Now similar thing you can do with the balloon also. Now here you will understand that there are two kinds of charges that can be produced. So what you do in this experiment, what they have done, they have taken two balloons, they rub both the balloons with, let's say, a woolen cloth. Now don't you think these two balloons will develop same kind of charge? Let's say the woolen one gets positive and the balloons get negative charge. Now what will happen? Now if I move both of these balloons close to each other, both are negative charge, so they will repel each other, as you can see in this diagram, correct? But if I move now this woolen cloth close to this balloon, what will happen? Because this woolen cloth is positive, this is negative, so they will attract each other and they will be attracted to each other or move closer to each other. So from this you understand that even in the charged objects there are two kinds. One is positively charged, other is negatively charged. Now that is just convention, which you call positive, which you call negative. Then now the force exerted by a charged body on another charged body or on an uncharged body is called an electrostatic force. This can be repulsive also. When repulsive, as you saw in case of balloon, if both have same charges, then they will repel also. Or if they have opposite charges, they will attract. Or if they have any charge and the other is uncharged, then also it will be attracted. Correct? Then next thing, last is this gravitational force. This is also non-contact, correct? If you are jumping, if an apple is falling from the tree, now why it moves down? Why it moves down? No contact, nothing. This is actually because of gravitational force. This is again a non-contact force. So the force which the earth attracts objects towards itself by is called gravitational force. It is again a non-contact force and it is always attractive in nature, correct? That is why it is not being repelled. Have you seen any object that falls from the tree? Not fall. It does not fall below. It starts going up in the sky. No. Why? Because gravitational force is not repulsive. Electrostatic force can be repulsive. Magnetic force can be repulsive, but not gravitational force. It is always attractive. So everything falls down towards the earth. Then it talks about weights and measurement. See, the force with which the earth pulls an object towards itself, this is called weight of the object. Correct? SI unit of weight is what? It is Newton. Fine. SI unit of weight is Newton. Now, if you take two springs like this, now what do you think? Intuitively also you understand, if this stone is heavier, then this will go much down, the spring will be stretched more. In this case, it will be stretched less. In this case, it will be stretched more. This you understand? This is the core philosophy that is used to make spring balance. Correct? So, this indicates that the earth pulls different objects with different forces. If it is heavier, force is also being applied is more. Correct? Spring balance is that same device. So basically you measure how much the spring is stretched, and from that you try to guess the weight of the object. Now see, converting from weight, converting, so there are two terms. Now what happens, people usually ask what is your weight, and then you tell, for example, 70 kg. Now what is the 70 kg? It does not make any sense. It is technically wrong. Weight should always be told in Newton. Correct? So actually if you see, you are like 7 kgs of mass, and then 10 is the gravitation, is the value of g. Okay, so you will understand about this. So this is like the force of gravity that is being applied, the acceleration by it. So this multiplied becomes 70 Newton, and wrongly we see that my weight is 70 kg. Understood? So this is weight, this is mass. Now can you see that this is just division by 10 sort of? Correct? So that means if I just get the weight using that spring balance, I can just divide it approximately by 10 to get the mass. What is mass? Mass we have already seen before. What is mass? Mass is the amount of matter in an object and is measured in grams. Understood? So we should not be doing this mistake as we are students of science. Now one thing it has mentioned is that, for example, if I am on earth, correct, and now I say that the force that I am applying on that weighing machine is 70 newtons, correct. Let's say this. Now if I go on moon, it changes. My mass does not change, I'm still made up of same things, matter is same, correct. So my mass is same but my weight changes. Now understand why. So on earth I am, let's say, of 1 kg, what I am, let's say this bottle is of 1 kg. Okay, now this 1 kg bottle on earth, what will be the weight? 10 newtons. Why? Multiplied by 10. On moon it will be only 1.6. Why? Because the value by which it is attracting, or the acceleration caused by it, is much lesser here. On Mars it will be slightly greater, in Venus it will be almost equal, in Jupiter it will be even higher. Correct? So can you see that weight is changing because of the place, correct, that is on earth or moon or what. Mass remains same. From this you will always remember the difference between mass and weight. Then last thing is floating or sinking. Now see this. So there is something known as buoyant force. So basically if you put anything in liquid, now what happens? Liquid is pushing it upward, that is called upthrust force, correct. And the gravitational pull, the gravity is pushing it down. This is how things work. Gravity is pushing it down, upthrust force is pushing it up. Now if they become equal, what will happen? The body will float. If the gravitational pull is stronger, upthrust force that is applied by the liquid is smaller, what will happen? It will sink, correct. And if the upthrust force is very high, gravitational force is not that high, like for plastic, what will happen? The upthrust is very high, so it will float right at the top of the surface of water. This is what you understand as floating and sinking. So in case of sinking, what happens? Gravitational force is greater than buoyant force. Now when you will have gravitational force high, As you understood, something that has more weight or more mass will have higher gravitational force, correct? So here, if mass, or more precisely if I tell you density, how dense is the object, if it is greater, then an object will sink. If it is very small, then it will float. Details of this we'll see in ninth class actually, that how this principle actually works. Okay, you can even calculate how much length it will go inside the water and how much it will float above. So these are the two forces in which, on which basis you define sinking and floating. This was first discovered by Archimedes. If you remember that guy who shouted Eureka, Eureka, that was the principle he came up with. Then, then you must have seen of some rocks that are floating. Like you might have heard of some rocks between India and Sri Lanka that are floating. It has mythological story also attached to it. Now, what are those? So those are usually, so one of the type of rocks that can float is pumice. Now, pumice is what? So basically, this is when lava is cooled down, correct? Volcanic lava is cooled down. A lot of gases, water vapor also cools quickly. Because of this, they get trapped there. Now, if gas and water is trapped, it is not of much weight, correct? So the stone or rock that you see here is not very dense, not very heavy. Because of which, what will happen? It will float on water, correct? It won't sink. So these are the kinds of rocks that float on water. Why? Because their composition is such that. Okay, so this is it for the chapter of forces as well. In the next one, we'll see the other chapters. That's it. Thank you.